Welcome everybody. In today's lesson we have an interesting question. We expected to solve and find the value of x. Now this is a quintic equation. The degree is x being 5, and because of that this might give us some challenge. So the question is x raised to the power of 5 positive 6 negative x raised to the power of 5 is equal to 1056. So this is a challenging question, but it is solvable if we were to perform a few manipulations. So foremost, what I wish to do is I would like to write x to the power of 5 as it is, but in case of 6 negative x, I would like to take a negative sign out and write this as negative of x negative 6. So this has to be raised to the power of 5. So clearly you can see that by doing this we are now in a position to totally rewrite this entire system as x raised to the power of 5. If we were to bring the negative sign out, that is raised to the power of 5. So that's going to be negative, and that is followed by x negative 6 raised to the power of 5 is equal to 1056. So this is the first manipulation that we have done, all because of the fact that we were able to take a negative sign out, and with simple algebra we were able to get this. So if I were to write this as 1, this is my new equation. Now from here, let me just take x negative 6 to be equal to y. And if I were to do that, I can rewrite equation 2 to be as x raised to the power of 5 negative y raised to the power of 5 is equal to 1056. Now this is the all-important substitution that we are making. We are taking x negative 6 to be equal to y, and we will make use of this all-important substitution all through this entire solution, thereby minimizing our effort. But apparently we are not going to achieve anything from x minus 6 being equal to y. So what we have to do is we will have to change this a bit, and that change is going to be occurring in this fashion. I will push this y to the left, and thereby I would now have x minus y, and I will move this 6 to the other side. So now I got a value. So as I mentioned to you now, what I would do is wherever I have x negative y, I would make the substitution 6, and with that I would be gradually able to eliminate the variable's degree, and subsequently I will meet up with a quadratic system which is easily solvable. So that is the basic idea behind this particular question. Now x raised to the power of 5 negative y raised to the power of 5 can be rewritten as x negative y times, I start with x raised to the power of 4 followed by x raised to the power of 3 times y, followed by x raised to the power of 2 times y squared, followed by x raised to the power of 1 times y raised to the power of 3, positive x raised to the power of 0, that's going to be 1, followed by y raised to the power of 4 is equal to 1056. This is a popular expansion for degree 5, x raised to the power of 5 negative y raised to the power of 5. And if you were to distribute this quantity, you will get this quantity back. You can try that out. Now having got this, I would now use this x negative y is equal to 6. So let me just take this as sum 3. So this is going to be 6 times of x raised to the power of 4 positive x raised to the power of 3 times y positive x raised to the power of 2 y raised to the power of 2 followed by xy cubed positive y raised to the power of 4 is equal to 1056. Now clearly if I were to divide by 6 both sides, this gets cancelled. In this case 6 divides 10 once and you have 4 there. 6 sevens are 42, so place the 7 there and you get a 3 being thrown out to join the 6 there, and that would mean 6 divides 36 6 times, so we got 176. So I will have to rewrite this as x raised to the power of 4 positive x cubed y positive x squared y squared positive x y cubed positive y raised to the power of 4 is equal to 176. Now what I wish to do is I would like to club these two together. So if we were to club these two together, I would have x raised to the power of 4 positive y raised to the power of 4 followed by x cubed y positive x squared y squared positive x y cubed is equal to 176. Okay, that's fair enough. Now I would like to write x raised to the power of 4 positive y raised to the power of 4 as a composition of x squared and y squared. How is it possible? I can rewrite this as x squared negative y squared raised to the power of 2. If I were to square this, I would get the first term. I will also get the term y raised to the power of 4, but I would have to handle minus 2 times x squared y squared, right? So I will have to get rid of this minus 2 squared 2 times x squared y squared. How do I do that? By adding 2 times x squared y squared. So I can add that, I can do that. So let me just add 2 times of x squared y squared followed by x raised to the power of 3 y positive x squared y squared positive xy cubed is equal to 176. Now what I wish to do is I would like to club these two together and write the system in this following fashion: x squared y negative y squared raised to the power of 2 followed by positive 3 times x squared y squared positive x cubed y positive xy cubed is equal to 176. So that's fair enough. Now what I wish to do is I can split this x squared negative y squared, right? I can actually split this in this fashion: x negative y times x positive y, and that is raised to the power of 2 followed by positive 3 times x squared y squared. Now I got a x cubed y. Let me take xy out. If I were to do that, I would end up with the x squared here followed by a y squared is equal to 176. That's fine. Now this can be rewritten as x negative y raised to the power of 2 times x positive y raised to the power of 2 positive 3 times x squared y squared positive xy times x squared positive y squared is equal to 176. Now what is this? X minus y. Clearly we can substitute the system from 3. X minus y is equal to 6. So this is going to be 36 multiplied, because x minus y is 6, 6 squared is 36, times x positive y raised to the power of 2 positive 3 times x squared y squared followed by xy times x squared positive y squared. Now what I wish to do is I would like to bring 176 to this side. So now you got an equation. The question is, how are we going to solve this? That's very critical. Now I would like to expand this x positive y raised to the power of 2. Now if I were to expand this, you will know why I'm doing it. This is going to be x squared positive y squared positive 2 times xy positive 3 times x squared y squared positive xy times x squared positive y squared negative 176 is equal to 0. My main idea is to club this with this. So now if I were to distribute 36, this would be 36 times x squared positive y squared positive 2 multiplied with 36 would be 72 x times y positive 3 times x squared y squared positive xy times x squared positive y squared negative 176 is equal to 0. So now we can club these together, and thereby I would take x squared positive y squared out. That would give me 36 positive x times y. So that is the reason I expanded followed by 72 x times y positive, you got 3 times x squared y squared negative 176 is equal to 0. So now we need to actually rewrite x squared positive y squared. So how do I do that? I need to make use of the system 3, equation 3. In fact, I want to make use of this. So what I would do is I will rewrite this as x negative y raised to the power of 2. I would get an x squared, I would get a y squared, but I would get an addition of 2xy with a negative sign. I need to get rid of that, so I will follow that up with positive 2 times xy. So now everything looks fine, followed by 36 positive x times y, positive 72 xy, positive 3 times x squared y squared negative 176 is equal to 0. So this is going to be 6 squared, so I get a 36 followed by 2 times xy, and then I have 36 followed by a positive xy, positive 72 xy, positive 3 times x squared y squared negative 176 is equal to 0. Now what I wish to do is I would like to take xy to be equal to t. If I were to do this, this would give me 36 positive 2 times t times 36 positive t positive 72t negative xy is t. So this is going to be 3 times t squared with a positive sign followed by negative 176 is equal to 0. Now let me distribute this. So this is going to give me 36 into 36, 36 squared, right, followed by 36t positive, this is 72t positive 2 times t squared positive 72t followed by 3 times t squared negative 176 is equal to 0. Now this is a quadratic system, and we will have to simplify this so that we can get the value. So that is an important part that we have to handle. So we got a 2t squared and a 3t squared. So we can add those two together. Is there any other square? So let me just add that. So this is going to give me 5t squared. Now you got 72. So that's going to be 4 and 144. And along with that, you got another 36. 6 added 10, and you got 5 with 3. That's 8 and 180. So what I did is I added this and this, all of these 3 things I added, thereby I got 180t. So now I got a 36 squared, so I need to take the square. 36 into 36, 6 6 are 36, 3 6 3s are 18, 2 1, and 6 3s are 18, and 1 3 3s are 9, and a 10. You get 6 and a 9 and a 2 and a 1 2 9 6 you have. So 1 2 9 6, you got to take away 176. So you get a 0 there, and you get a 2 there, and you get a 1 and a 1. 1120. So that's going to be plus 1120 is equal to 0. Now I got a 5 here. I'm going to be dividing by 5. So this is going to be t squared positive 5 3s are 15, and take and move the 3 on the other side. You get 36t followed by 2 times 5 2s are 10, and then you have 2, and then you have 4. So this is what you got. A beautiful quadratic system. T squared positive 36t positive 2 to 4 equal to 0. So if you were to solve using the quadratic formula, so t is equal to negative 36 plus or minus root of b squared minus 4 times a and c divided by 2 times a. So this is what you've got. So we need to do some arithmetic here. 36 squared, we already know 36 squared is 1296. Now 4 4s are 16, 1 4 2s are 8, 9, and 4 2s are 8. So 16, 1. Okay, let's take the values out. 6 minus 6, 0, and this is going to give me 0, and this is going to give me 400. So this is equal to negative 36 plus or minus root of 400 divided by 2, which is equal to negative 36 plus 20 divided by 2, which is going to be 16, right? Negative 16 divided by 2, which is going to give me negative 8. So t is equal to negative 8. That's going to be one value. So let me have that one value. The next value, when you got negative sign, this is going to be negative 56 divided by 2 is going to be 28. So the next value, t is equal to negative 28. So you got two values, negative 8 and negative 28. Now we have actually taken xy is equal to t, right? So we will have to substitute that and then solve for x. So let me move on to the next page. So clearly we have got xy is equal to t, but the value of t we have found out to be as t is equal to negative 8, that's one value, then t is equal to negative 28. So if we were to substitute that, we get xy is equal to negative 8 and then xy is equal to negative 28. But we also have another expansion, or I should say another substitution that we took. Okay, we know that x negative y is equal to 6. This is the substitution we were utilizing. But how did we get this? Okay, we started off by taking x negative 6 is equal to y, right? These were all shown to you in at the start of this particular question. So what I would do is I would substitute the value of y over here. So using this can be rewritten as x into, in place of y, I'm going to substitute x negative 6 is equal to negative 8. This is going to be x squared negative 6x. Negative 8, I moved up to the left side, I get positive 8 is equal to 0. So that's one equation which we can use and find the value of x. But x is actually quintic, right? So let's see how many roots or how many values of x we are able to obtain. Now the next step here is I'll do the same thing. X of x negative 6 is equal to negative 28. In this case is going to be x squared negative 6x positive 28 is equal to 0. Now over here, if I were to apply the quadratic, we will end up with an imaginary roots. So this is going to be 6 plus or minus root of 36 negative 4 times of 28 divided by 2 times of a. So clearly you can see that this is going to be a negative quantity, but we want only real x. So this has to be dropped. So we are dropping this. Why are we dropping this? Because this is producing us a complex roots. So we don't want complex roots. We want only real values of 4x. Let's see what are we getting from here. X is equal to, this is going to give me 6 plus or minus root of 36 negative 4 times 8, 32 divided by 2, which is equal to 6 plus or minus root of 36 negative 32 gives me 4 divided by 2, which is going to be 6 plus 2 divided by 2, 8 divided by 2 is equal to 4, and the other side is 6 negative 2 divided by 2, 4 over 2, which is equal to 2. So I've got x being equal to 4 and x being equal to 2. So these are the values of x. So if you were to make the check, right? So let me make the check. So we started off with this system. What was the system? X raised to the power of 5 positive 6 negative x raised to the power of 5 is equal to 1056. So if you were to substitute x is equal to 2 power of 5 positive 6 negative 2 raised to the power of 5, we should get the right hand side. So this is going to be 32, and this is going to be 6 negative 4 is 6 negative 2 is going to be 4 raised to the power of 5. So let me check out what is 4 raised to the power of 5. So 4 times 4 times 4 times 4 times 4 is a 16, and you got a 16 here, and then you got a 4. So 16 into 16, 36, 3, 9, 6, 1, 6, 15 and 2, 256 multiplied with 4, 24, 2, 22, go to the 8, 9, 10. So you get 1024. This has to be added with 32. And let's add that up and check it out. So 1024 added with 32 gives me 6 and a 5 and a 0, 1056. So you get 1056, which is equal to the right hand side. So this is a beautiful question, students, where I have obtained all real values of x that satisfies the given system. Thank you everybody. Enjoy your night.